So in this video, I explain some basic things that everyone must know to study the analytical geometry of 3 dimension. Some formula I state or I give the formula, and for this year topic is sphere, cone and cylinder. Sphere, cone and cylinder. In analytical geometry, plane geometry, you have studied how to represent a point in the plane. I consider Cartesian coordinates, rectangular Cartesian coordinates. You have studied how to represent a point in the plane. You have studied what is plane in detail in 12th standard and 11th standard. You have studied solid geometry. There you have studied how to represent the point, and also what is the distance between the points, and what is the plane, and so on. Now I try to do the revision, but in very short time I do the revision. I tell you the summary of that you have studied in 11th and 12th standard. It may help for your study of this spheres, cones and cylinders. First, consider the plane geometry. Plane means two-dimensional. Best example for plane is surface of the blackboard is a plane. Surface of the blackboard is a plane. Or you can take any paper that the surface of the paper becomes a plane. That is a good example for plane. Now, in the plane, how do you represent a point? To represent a point in the plane, we consider two perpendicular lines, mutually perpendicular lines. And we name that as coordinate axis, x dash ox, y dash oy. And a point is represented in the plane, means in this plane, with reference to these two perpendicular lines. They are taken as coordinate axis. Now we draw the perpendicular like this. If this OM is x, I take OM is x, PM is y. Then coordinates of the points are taken as xy. Therefore, what are the coordinates of a point in the plane? Coordinates of a point in the plane are nothing but they are the perpendicular distances from two mutually perpendicular lines. So what are the coordinates of a point in the plane? They are perpendicular distances from two perpendicular lines. And perpendicular lines are known as coordinate axis. And here distance from y-axis is taken as x coordinate. Distance from y-axis is taken as x coordinate. Distance from x-axis is taken as y coordinate. And important thing is these two perpendicular lines divide the whole plane into four parts. 1, 2, 3, 4. 1, 2, 3, 4. 4 parts, and they are called quadrants. And the rest of the things you know how to what are the signs of the coordinates in the different quadrants, first, second, third quadrants, and so on. That is plane geometry. That is called plane geometry. But the thing is, now I explain a practical problem here, practical situation. Suppose you have to know the position of a tip of the fan in this room, tip of the fan. Then that is in the space. Tip of the fan is to represent the position of the fan, that is in the space. For that, only two distances are not sufficient. For that, height is also required. Height is also required. To represent this object, suppose we have to represent this object. What is the position of this object? That is the duster. For that, I take distance of this duster from this wall. That is from the blackboard. One distance. Another distance from adjacent wall, but that too are not sufficient. they give this duster is at a distance, some distance from these two walls, but that height is required. So to represent a point in the space, three coordinates are required, or three things are required: distance from one wall, second wall, that is adjacent wall, and also height. And they are known as coordinates of the point. So to represent the point in the space, we require three mutually perpendicular lines. Now the three mutually perpendicular lines are taken like this. One is x dash ox, and z dash oz, and also we take another perpendicular line. In the plane we cannot take three perpendicular lines. We take x dash ox and x dash ox, z dash oz are perpendicular lines in the plane of the blackboard, and this y dash oy is, you have to imagine this y dash oy is perpendicular to this plane of the blackboard, and y dash oy is directed towards you, or directed towards me. That is, y dash oy is perpendicular, and it is like this. Perpendicular like this. It is the perpendicular. Now, so we can imagine three perpendicular lines here: xox, x dash ox, z dash oz are in the plane of the blackboard, and y dash oy is towards us. That three perpendicular lines. Now, how to represent the point? Suppose P is a point. Then what are the coordinates of this point P? For that, we have to draw three planes through this point and perpendicular to this axis. X dash ox is called x axis, z dash oz z axis, y dash oy is called y axis. Three perpendicular lines, and these three perpendicular lines divide the space into 8 parts. You know that two perpendicular lines x dash ox, z dash oz divides the plane into 4 parts. Correct? 4 parts. Now this one is, what is that? Y dash oy is towards you. It is perpendicular to the plane of the board. These three perpendicular lines divide the complete space into 8 parts. They are called octants. Now by taking these perpendicular lines, I take the perpendicular lines like this. Just to explain, say how many perpendicular lines are there? 3 set of lines. I have taken 3 pens here. 3 pens for 3 perpendicular lines. One perpendicular line, one line, second line, third one. 3 perpendicular lines. These 3 perpendicular lines divide this space into 8 parts. What are the 8 parts? 1, 2, 3, 4. 1, 2, 3, 4. That is above this. And below this there are again 4 parts. 1, 2, 3, 4. See, above this point, that is can be taken as origin, intersecting point of 3 lines mutually perpendicular. Above this line 4 parts are there. 1, 2, 3, 4. And below this point there are 4 parts. 1, 2, 3, 4. Totally 8 parts. 3 mutually perpendicular lines divide the space into 8 parts. They are called octants. Now to represent the coordinates of the point. How do you represent the coordinate of the points? For that we draw 3 planes perpendicular to the 3 axes. X axis, y axis, z axis. And the planes are like this. I draw the planes here. This is the first one. perpendicular to the x-axis. It is perpendicular. It meets x-axis at this point. Perpendicular. This is like this, perpendicular. Now I draw other three planes. Other three planes. Other three planes. Three planes which are perpendicular to the axis and parallel to the coordinate planes. Here XOZ is called XZ plane, or ZOX is XZ plane, ZOY is ZY plane, YOX is XY plane. YOX is XY plane. We have drawn planes parallel to the coordinate planes. XOY plane parallel, and this is parallel to YZ plane, and this is parallel to XOY plane, XY plane. I have drawn three planes here parallel to the coordinate planes and perpendicular to the axis. Perpendicular to the axis. Now, this distances, that distance OA and OB, OC, correct? OA, OB, OC. They are the points where the planes drawn perpendicular to the coordinate axis meets the axis at the point. This plane is perpendicular to XY plane, meets at A, correct? And this plane meets at C. This plane, what is that? This plane, this rectangle, it is plane. This meets at B, that is y-axis at B. This plane meets x-axis at A. This plane meets y-axis at z-axis at C. This plane meets y-axis at B. And these distances OA, OC, OB, they are the coordinates of the points. Coordinates of the point. This OA is called x coordinate. OB is called y coordinate. OC is called z coordinates. And this point is written as, coordinates are written as XYZ. XYZ. Therefore, what are the distance of this point P from, what are the coordinates of the point P? They are the distances, perpendicular distances from XY and Z axis. What are the perpendicular distances? Perpendicular means, say it is not a plane, or I have taken three perpendicular lines here. You have to imagine this P, from P, if we draw a perpendicular plane through P and cutting this OX perpendicularly, then it meets x-axis at this point. At this point. And if we draw a plane through P perpendicular to this line B, that is y-axis, then it meets y-axis at this point. This perpendicular plane through P to z-axis meets z-axis at C. And these OA, OC, OB are called XYZ coordinates of the point. Therefore, what are the coordinates of a point B? They are the perpendicular distances from x-axis, y-axis, z-axis. Correct? Z-axis. Or by using this diagram, this is y coordinate and this is z coordinate. This is also x coordinate. This is x, this is z, this is y. Because they are the using that parallelepiped. We have drawn a parallelepiped here. Using the edges of the parallelepiped, since these two are same, this distance is same. This y coordinate is also, this is y coordinate, this is x coordinate, this is z coordinate of the point. So in another way, how do you define coordinates of a point? In 3 dimensions, x coordinate of a point is perpendicular distance from x coordinate of a point is perpendicular distance from yz plane. See, this is yz plane. This is YZ plane. ZOY is called YZ plane and it is perpendicular. It is called X coordinate. So in 3 dimension, X coordinate of a point is perpendicular distance from YZ plane. What is Y coordinate? Y coordinate is perpendicular distance from YZ and Y coordinate is XZ plane. XZ plane, perpendicular distance from XZ plane. This is XOZ is XZ plane and it is the perpendicular Y coordinate. What is the Z coordinate of a point? Z coordinate of a point is perpendicular distance of the point from XY plane. So I think all of you understood this one. In plane geometry, coordinates of a point P are perpendicular distance from X and Y axis. Perpendicular distance from Y axis is called X coordinate. Perpendicular distance from Y axis is called X coordinate. X axis is called Y coordinate. We write XY like this. But in 3 dimension, coordinates of a point are perpendicular distance from coordinate planes. Distance from XY plane is called Z coordinate. Perpendicular distance from YZ plane is called X coordinate. Perpendicular distance from XZ plane, XOZ is called XZ plane. It is called XZ plane is Y coordinate. This is about coordinates of a point. Coordinates of a point. Therefore, what are the coordinates of a point in 3-dimensional space? Coordinate of a point are perpendicular distance from coordinate planes. Perpendicular distance from XY plane is Z coordinate. Perpendicular distance from YZ plane is YZ plane is X coordinate. XY plane is Z coordinate and XZ plane is Y coordinate. We define coordinates like this. This is about coordinates of a point. And what you have studied in 11th and 12th standard, how to represent a point. I explained how to represent a point. And first thing is distance between the 2 points. Distance formula. Distance between x1, y1, z1 and q, x2, y2, z2 is given by, what is the distance? PQ is square root of x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. See, this is important. Now formulae are important. This has been already derived. I give the only summary of that things you have studied in 11th and 12th standard. First formula required is this one. You go through the coordinates of a point. You go through again and again. You have to read again and again. Then you will you can understand what are the coordinates of a point. Now, this is the first formula, distance between the 2 points, and second is midpoint. What is the midpoint formula? Midpoint of line joining these two is x2 plus x1 upon 2, y2 plus y1 upon 2, z2 plus z1 upon 2. Distance, that is midpoint formula. And section formula. Actually, midpoint formula means it is a particular case of section formula. What is section formula? Suppose a line segment joining PQ is divided in the ratio m is to n. What are P and Q? Same. P is x1, y1, z1, Q is x2, y2, z2, and line segment joining PQ is divided in the ratio m is to n. Then that coordinates of that point is given by mx2 plus nx1 by m plus n, my2 plus ny1 upon m plus n, mz2 plus nz1 upon m plus n. These are the coordinates of a point which divide line segment joining PQ in the ratio m is to n. Distance formula, section formula, midpoint of a line joining PQ. Next is concept is direction cosines of a point. That is important. Direction cosines. Direction cosines. This plays very important role in study of solid geometry. What do you mean by direction cosines? Direction cosines is like this. We have taken x dash ox and z dash oz are perpendicular lines like this. Now, suppose P is any point. If OP makes an angle, alpha with positive x-axis, then cos alpha is called direction cosine of this line OP, and cos alpha, cos beta, cos gamma are called direction cosines of this OP, where alpha, beta, gamma are angles made by this OP with positive xyz axis respectively, and they are denoted by L, M, N. So direction cosines, they are cos alpha, cos beta, cos gamma. What are alpha, beta, gamma? Angle made by this OP with positive xyz axis. Now it is if this LMN are direction cosines of the point and OP is equal to R, then this cos alpha is, or L is x by R, M is y by R, N is z by R. If distance OP is R and x, y, z are coordinates of the point, then L is given by x by R, M is y by R, N is z by R. Or we represent x is LR, y is MR, N is ZR. So this is important, this relation. What is R here? Distance OP. X, Y, Z are coordinates of the point. If L, M, N are the direction cosines, then L is given by x by R, M is y by R, N is z by R. This is because draw the perpendicular. Suppose P L is perpendicular. While explaining coordinates of a point, I explained what is the x coordinate of a point. Correct? This is x axis. What is x coordinate of a point here? X coordinate of a point is distance, perpendicular distance means you have to draw a plane through this, correct? This through this P, I draw the plane like this. You refer that diagram here. It is like this. You have to draw a plane, perpendicular plane. It meets this is the point here P. It meets this perpendicular plane you have to draw. And this point L is the foot of the perpendicular here, drawn from P to this line. Therefore, this is perpendicular now. What is that? This is perpendicular. Correct? This is perpendicular. PL is, sorry, just a minute. PL is perpendicular. You have to draw a plane through this point P. 1 minute. Draw a plane through this point. That means plane is like this. You have to draw the plane through this point P. Correct? And this plane where it intersects x axis is like this. Correct? It is like this. You have to draw a plane through P perpendicular to this. What is that? Perpendicular to what is x coordinate of a point? X coordinate is, it is the perpendicular from YZ plane. YZ plane. You have to draw a plane through this point which is perpendicular to the YZ plane. This plane is perpendicular to the YZ plane. Because what is YZ plane? We have to draw a perpendicular line here. This is Y dash OY is perpendicular to both these two, and YZ plane is, this is the YZ plane. Correct? This is the YZ plane. We have drawn a plane through P perpendicular to this YZ plane, and it meets x axis at this point. What is that? E. Therefore, this is perpendicular. This is perpendicular. This is perpendicular because this line is perpendicular to this plane. Correct? This plane. Therefore, PA is x coordinate of the point. PA is x coordinate of the point. This is alpha. This is x. OA is x coordinate of the point. Correct? X coordinate. What is x coordinate of the point? OA is x coordinate of the point. X by r. This is r. What is that? This is r. R. X by r is cos alpha. X by r is cos alpha. I think this is clear now. We have taken OP is equal to r, and OP makes an angle alpha with x axis, positive x axis. Then cos alpha is x by r, and this is taken as direction cosine of the line. Similarly, cos beta, cos gamma are taken as direction cosines of the line. Cos alpha, cos beta, cos gamma are taken as direction cosines of this OP, which makes an angle alpha, beta, gamma with positive xyz axis. Now, I have proved here cos alpha is x by r. Why cos alpha is x by r? Because what is x here? OA is equal to x, and PA is perpendicular here. PA is perpendicular to this OX. Therefore, this cos alpha is x by r. Cos alpha is x by r, and this cos alpha is usually denoted by L. And L, M, N are known as direction cosines. The important relation is L square plus M square plus N square is 1. You can derive easily from this. L square, M square, N square is 1. And what are the next things? Projection of a line on the another. Projection of a line. Suppose this is the line, coordinates are PQ, and P is x1, y1, z1, Q is x2, y2, z2, y2, z2. Then projection of this line on another line whose directions are, cosines are LMN. Direction cosine of this line are LMN. Projection of PQ on this line is this. This is the projection. If you draw a perpendicular from here, perpendicular, then this is called projection. And this projection is given by x2 minus x1 into L, y2 minus y1 into M, z2 minus z1 into M. Projection of line joining PQ on another line whose direction cosines are LMN is given by this. We may use this result. I only explain what are the results to be used while studying sphere, cone and cylinder. Next is what is the angle between the two lines. You have studied formula cos theta is, suppose theta is angle between the two lines whose actual direction cosines are L1, M1, N1, L2, M2, N2. Then cos theta is L1, L2 plus M1, M2 plus N1, N2. This is the angle between the two lines. Then section formula, distance formula, projection of one line on the another, midpoint formula. These are the some basic things that you have to go through again and again. To understand this, you have to go through again and again. You can refer Analytical solid geometry by Shanti Narayan. Shanti Narayan. Analytical solid geometry by Shanti Narayan. And first you go through the basic things. Then in the next video, I start the actual syllabus. Start from sphere. Actually, this year topic is easier than these basic things. Always basic things are very difficult to understand. If you once understand the basic things, then the next topics will be very easy. Okay, go through the video. If you have any difficulty, you can ask at any time. Thank you.